are all actually elliptical in shape.
Simulations indicate that the impactor would have to have been around 1,200 miles in diameter, or roughly the size of Pluto, hurtling through space at 20,000 miles per hour and striking Mars at a 45-degree angle.
So it's an enormously energetic impact.
Not surprisingly, the Mars impact is estimated to have occurred during the late stages of our solar system's formation, 4 billion years ago. And it is one of two massive planetary impacts that still scar our solar system. Evidence of the other impact can be seen in the off-kilter attitude of Uranus. As solar system planets go, Uranus is fairly dull. It has rings, but they are not nearly as spectacular as Saturn's. An ice giant, Uranus is puny compared to its gas giant neighbors, Jupiter and Saturn. Like Earth, Uranus has a solid core, but this is where its similarity to Earth ends.
We couldn't land a spaceship on it. It's got a thick atmosphere, so heavy that it was almost like a pudding.
And that pudding sits on a bed of ice that makes up the ice giant's mantle. But the one spectacular feature that sets Uranus apart from the other planets, Uranus is extremely askew. For years, this strange alignment of Uranus baffled astronomers. But one leading theory first suggested by Soviet astronomer Viktor Safronov in the 1960s suggested that the cause was a massive impact from an object perhaps as big as Earth.
All planets have a rotation axis, so here's the planet, here's the North Pole, South Pole, and we're leaning at 23.5 degrees, Mars is leaning at 25 degrees, Jupiter's about 0 degrees. But Uranus is very strange because it's actually tipped a little bit past 90 degrees. And Safronov pointed out that you could do that by hitting Uranus with something that, as I remember, was 3% the mass of Uranus itself. So imagine a planet rotating like this. It's a round planet. It gets maybe hit tangentially right at the top. That tips it over, the debris gets thrown off, and you've now rotated this planet off to the side.
Not only do impacts knock planets on their side, like Uranus, and give the surface of planets complete makeovers, like what happened to Mars, but objects can hit planets so hard, pieces break off, only to fall into other planets. We know meteorites can land in fields, deserts, and just about anywhere else. But every so often, these meteorites are actually dislodged chunks of other planets, bringing us information from